So we started section 4.4 last week. We stopped, reviewed, did a whole quiz and things. Now we're going to pick up where we left off. So the last example that we did was example 6. So example 7 just picks up right where we left off. So we are first going to figure this out using the Pythagorean theorem like we learned last week. Then I'll show you the distance formula, how they work together, and then we'll finish the notes, give you homework, go over the quiz. So the way we're going to do these, we're going to graph the ordered pairs. We're going to make a right triangle. We're going to find the distance between the 2 points. Okay? So to graph point A, we're going to go right 1 up 2. To graph point B, we're going to go right 4. 1, 2, 3, 4 up 6. Okay, so I want to find this right here. So we learned last week that if you have a right triangle, you can do side squared plus side squared equals hypotenuse squared. So I am going to make a right triangle here where one of the legs is 3 units. The other leg is 1, 2, 3, 4 units. I'm going to square both of those. I'm going to add them together. That's going to be the distance. It's like making the distance the hypotenuse of a right triangle. Does everyone see what I'm doing here? Okay? So this would be 9 and 16 and c squared. 25 equals c squared. So what's c? 5. I called it a question mark. You can call it c, whatever. But the distance here is 5. I took the square root of both sides. Okay?
Yes, ma'am.
Now, if you look at this side length, we just counted the jumps, right? It was 3. Do you see how 3 is also the difference between these two if you would subtract the x's? That's not a coincidence, okay? Same thing here. The side length is 4. If I do 6 minus 2, I would get 4. So you can see how we can find the distance using the Pythagorean theorem. I'm going to show you one more time, and then we're going to actually look at the distance formula and how it's related to these things. All right. So if I'm going to graph point C, I go left 1, I go up 7. To graph point D, I go right 5. I go down 1. Same idea. I am going to make this one big right triangle. So let's figure out how long these sides are. We have 1, 2, 3, 4, 5, 6, 7, 8. So one of the legs is going to be 8 units long. The other one is 1, 2, 3, 4, 5, 6 units long. And I am looking for the hypotenuse. I'll call it C this time. So I'm going to do 6 squared plus 8 squared equals C squared. So 36 plus 64 equals c squared, which is 100. So how long is that hypotenuse? 10. You take the square root. What number times itself? All right. And then notice, 8 was the side that goes up and down, right? Do you see how the distance between these 2 points, or the difference between the y values, is 8? And here we had 6 units, and the difference between the x values is 6. Are you guys seeing what I'm seeing? Okay. So we're going to use that, and we're going to use this pattern to actually come up with a formula so that we don't have to draw a triangle every time. So basically, one leg of the triangle is the difference between the x's. The other leg of the triangle is the difference between the y's. You always square those differences and then take the square root. That's the distance formula, and that's how it relates to the Pythagorean theorem. Okay? So basically, this is what we did on the last ones. We just did a picture. Okay? So, I mean, to be honest, and this might be my headache talking, but you can just write that part. So you're going to have two ordered pairs. One point is A, one point is B. If I'm looking for the distance between A and B, here's what we do. So we subtract the X's. That's like one of those legs. We subtract the Y's. That's like the other leg. Square them, add them together, take the square root. It's the same thing as we did on the last two examples. This just saves us from drawing that triangle and counting the jumps every time. Here's our first example actually using the distance formula. So instead of, the whole writing it out, graphing it, counting the jumps, we're just going to use that distance formula. So here is the distance formula. So what I need to do is label these. Some people do this step, some people don't, but since it's our first one, I will. This is the first X I was given, so I'm going to call it X1. This was the first Y I was given, so I'm going to call it Y1. Second X, second Y, and then you basically just plug them in, do the math. So I'm going to have a big square root. I want the second X first. What is the second X? 3. Minus, what was the first X? 1. Square those. Plus the second Y minus the first Y. Square it.
You put 2 minus signs.
I sure did put 2 minus signs. Thank you for noticing. All right, what is 3 minus 1? 2. We'll have 2 squared. Plus, what is 3 minus negative 1? 4. What is 2 squared?
4.
What is 4 squared?
16.
What does that give me?
20.
Square root 20. Can someone type in the square root of 20 on their calculator, please? Hold on one second. Let's see if we can get an answer. What is it?
4.47213.
4.47? So we're going to round that to 4.5. If it says to the nearest tenth, that's what you do. If it says simplify the radical, that's when you do this guy. Okay? And the 2's come out and the 5 stays inside. We talked about that a little bit last week when we were reviewing. So depending on the question. Here it does not specify. So those are the both methods. Okay? I will check real quick to see what your homework asks for. The homework says round to the nearest tenth, so you can do this. But down the road, if you see something that says simplify the radical, you got to do this. All right? So both options. For the rest of the notes and for the homework, we'll just go with the calculator version. So now we have points C and D. We're going to plug them into that same formula. So the formula is listed there. It's not going to be listed like on your homework and such. So don't think this is going to be information you're just given every time. But since we're still learning, I don't mind showing it to you. Okay? So the first thing I want is the difference between the x's. Now, I told you to do x2 and then x1. The cool thing is it doesn't really matter because let's say you did -4 minus -3, you'd get a -1. When you square -1, it turns into a positive. Or if you did -3 minus -4, you get +1. When you square it, it's still positive. So if you flip-flop them on accident, it's not going to be a big deal. As long as the x's are together, subtracted and squared, the y's are together, subtracted and squared. Okay? But I'll just go the way the formula says. So the formula says the second x, so negative 3, minus the first x, square it, the second y, minus the first y, square it, and take the square root. All right, so negative 3 minus negative 4 gives me a 1. Square it. Negative 3 minus 3 is negative 6. And I square it. What is 1 squared? 1. What is negative 6 squared? Absolutely incorrect. Positive 36. That's what I mean by order doesn't matter. Because if you would have rewritten it the other way, you would have got 6. 6 squared is 36. Negative 6 squared is also 36. So make sure if you're using the calculator, putting the negative in parentheses. Okay? Remember, this is a distance. Distance is never negative. All right. So when I add those, I get square root 37. What is the square root of 37 rounded to the nearest tenth? Yes. 6.1. Sounds good. What are your questions? I'm going to write a little less this time because I think some of this you can start doing in your head. So we are going to subtract the x's. So x2 is 5, x1 is 0. Subtract the y's. So y2 is 3 minus a negative 2. Square that. What is 5 minus 0? And what's 5 squared? 25. What is 3 minus negative 2? 5. And what's 5 squared? 25. Good. Got a little excited with that. All right. So that's square root of 50. And when you type that in your calculator, what do you get? 7.1. Sounds good to me. I know the square root of 49 is 7, so that makes sense. What are your questions?